Hello, and welcome to Understanding Functions Graphically and Numerically. My name is Tuesday Johnson. Here's an introduction to a concept. So let's talk about the vertical line test first. So for the graph to be a function, whatever a function is, right, every vertical line must intersect the graph in at most one point. So let's take a look at this graph of a circle over here. Vertical line. So vertical lines. All right, so we could take any vertical line. Oh, there's a vertical line that hits it twice. So this is not a function. So using all of our vertical lines, every time I hit the graph, it only hits once, right? So this is a function. But if we take, this is called a parabola. If we take the parabola and we lay it on its side, here's a line that, well, let's suppose I could draw a straight line. There's a line that hits it only once. But every vertical line hits the graph of a function at most one time. So this is not a function. What about this one over here? Well, a vertical line looks like maybe it'll hit it, but notice that this keeps getting wider and this keeps getting wider, and we never actually hit any vertical line. So this is a function. Okay, so we haven't even seen the definition of a function yet. But graphically, we can use a vertical line test to see what's up. All right, so we'll get to function. Don't worry, we'll define that. Use the given graph to evaluate the function. So here's our function, right? So just some function, f of x. Here's our x-axis, and I've made all of the dots a little easier to read. So the first thing we want to do, there we go, f of 2. Okay, so our function in general is f of x, right? So here there's a 2 in place of the x. So I'll look for the 2 on the x. See, that's 5 and that's 0. So this must be 2. So here's the 2. Now where does that x value of 2 hit the graph? Oh, right here, right? Right there. So what is that value? This is a -3. Let's write that correctly without using a mouse. F of -1. Right, here's 0. Let's go back 1. This is -1. Where does it hit? It hits right there at 0. Now, we could also do a little bit of arithmetic, a little bit of algebra, if you will, with our functions. So I'm going to find f of 3, and I'm going to take that answer, and I'm going to multiply it by 2. So if this is 0, 1, 2, here's 3, right? So that's a 0. F of 3 equals 0. That's not what I wanted at all. Oh. Sometimes we have to erase. Everybody makes mistakes. All right, f of 3 equals 0. So I'm going to do 2 times 0 plus. Now I need to find out what f of 0 is. So when x value is 0, I follow it down. And right here is 5, 4, minus 3 again. So I'll have 2 times 0 plus a -3, which equals 0 minus 3. So my answer is -3. So we could do our little substitutions in order to find each piece. Once we have the pieces together, we could solve the entire equation. All right, so let's look at another table of values. Graphically, we could tell when we have a function because of the vertical line test with the numbers. We could use graphs as well, or we could just look at the tables, and I'm going to do both. Input of 3, output of -2, 5 to 4, 8 to -5. Let's just take a look at it. All right, so an input of 3, output of -2, input of 5, output of 4, input of 8, output of -5. Here's a 6, 3, here's a 7, -2. Notice that each input has exactly one output. And they might have the same output. That's okay, right? Two friends can go to the same place, but one of these inputs can't go to two different places. So this is a function. We could tell vertically with the vertical line test if we choose to plot it, but we can also tell because each input only goes one place. They might go the same place, that's cool, but each one only goes one place. In contrast, because you know this is going to contrast, input of 1, output of 7, input of 2, output of 4, 3 goes to 3, 4 goes to 1, 2 goes to -1. Now, just looking at the table, see how the 2 has 2 different inputs. Imagine that was you, right? Could you be in 2 different places at the same time? That's a scheduling problem. And we can see here with the vertical line test, if we were to plot these, right, it wouldn't pass the vertical line test either. And so this is not a function. All right, so each x value can go only one place in the y values in order to be a function. So each x connects to at most one y value. And I shouldn't say at most. Because each of our x values needs to go somewhere, we can't have a value here of 4 that doesn't have an output. All right, so each x connects to only one y value. And that's a not very official, but a general idea of what a function is. All right, so let's evaluate just using a table, no graphs, just let's take a look and see how we would deal with this. Okay, much like the graph, we have an x inside of our parentheses for f of x. So here we replace the x by a 4. So I'll find where the x is 4. Okay, what's the output? Well, when the x is replaced by 4, the output is replaced by 6. F of -2. So here x is the -2. -2. What maps with that? What pairs with that? A 7 does. And now we have a problem, right? Not a problem like it's difficult, but we have an arithmetic problem. So we'll have 3 times. Now down here, I'll find what is my f of 3. Here's 3, it goes to 4. So 3 times f of 3, that's 3 times 4, minus f of 1. F of 1 goes to 1. So we've rewritten the problem, 3f of 3 minus f of 1 as 3 times 4. There's a assumed multiplication in here. We don't write it a lot. Mathematicians are lazy. There's some things we just don't write, and they're assumed. And so sometimes we need to remind students that that's what that means. So that's 3 times f of 3. But f of 3 is telling us how to find our number. We found the number, it's 4. So that's 3 times 4 minus f of 1 happens to be 1. So 3 times 4 minus 1, that's 12 minus 1 is 11, our answer. Looks like a pause button. All right. That's going to be it. Functions numerically and graphically. Thank you so much for watching. Have a great day.